All right, here we go. Let's take a look at the next section. If you like the last one on use substitution, you're going to like this one. It's the same thing. If you didn't like the last section, huge bummer. You got another section of it. So the only difference here is we're going to look at a definite integral instead of the indefinite integral. So we've got some upper boundaries and lower boundaries here. And let's do our u substitution. So we're going to do the same thing, but now we're going to evaluate that. So in this case, I look at the u. To me, it's probably this part in the parentheses where I'm going to start. And I'm going to say it's t cubed plus 1. Not sure if that's right or not, but we're just going to go ahead and see what happens. I kind of picked the most complicated thing. Take the derivative of that. So the derivative, and I'm going to go straight to the du here, will be 3t squared. The 1 disappears, so it'll be dt. So do all these parts match up? Sure. Well, I hope they do anyway. So I'm going to show you two ways. One, we're going to just do normal u substitution. Another one we're going to do with the change of boundaries, kind of like the little shortcut way. But just to show that it works is, I definitely know I got my u right here in red. That's going to be my u, and it is squared. But I've got this left over, and I like to show this in a different color here. We got the t squared and the dt. Does that come down here and work? Sure, but we kind of have to clean this up. That 3 is a little bonus, so we're going to divide both sides by 3. Divide that by 3, so we really get 1/3 du. Those cancel, gives me that t squared dt. So there it is in blue right there. I've got all the extra stuff I need. So really I can rewrite this as the integral from 0 to 1 of the t squared dt is gone, so that it turns into my u squared du. Don't forget about that 1/3 goes out front. Now I've done the u substitution. Awesome. So that was like we did last section. Now we're just going to evaluate this bad boy. So all we're going to do is leave this 1/3 out front, and we're going to integrate this thing. So bump it up to what, u cubed, divide it by that 3, so it's 1/3 u cubed, and we're going to evaluate that from 0 to 1. We can't quite evaluate yet, though, until we put the x backs in there. So if I'm going to sub the equation back in there, u is really t cubed plus 1. All of that is cubed. Now I can evaluate it from 0 to 1. So I got to change the u back into my t, and now I can evaluate from 0 to 1. So I'm looking at here 1/3, and then let's put the 1 in. I've got 1/3, 1 cubed, plus 1. All of that cubed is the first chunk. Now I'm going to do it with the 0. I'm going to minus, and this should really be its own parentheses. Remember, it's this whole first part. Oh my gosh, this is intense. The whole second part will be plug 0 in for t, so it's 0 cubed plus 1, the whole thing cubed. So I showed every single step there. That's kind of intense, and I'm going to show you a shorter way over here with changing the boundaries. But let's finish this out, make sure we get the same thing. So we got 1 cubed plus 1 is 2, 2 to the 8. I'm sorry, 2 to the 3rd is 8, so that'll be 8/3 when I multiply that out. And then what's going to happen here, I got 0 plus 1 is 1, cube 1, you get 1, minus 1/3. So it looks like I'm going to get 8/3 minus 1/3 is 7/3. Finally times that by that 1/3, I'm looking at 7/9 is that integral. So that, if I evaluate this definite integral, I'm going to say it equals 7/9. Awesome. That was pretty intense to switch back. What we really like to do, I just want to show you that it works though, is we really like to change the boundaries. So if I go back to this, so we're going to solve this for u. What I'm going to do is change this into u. So right now my boundaries are in t, this variable t, from 0 to 1 referring to the function with t as the variable with respect to t. If I'm in u, what I can do here is change these boundaries so it's not really 0 and 1 with u. I probably shouldn't even wrote that there. What this really is I'm going to switch it over. So how do I find that? Well, u equals t cubed. You're going to plug these into the t, so it's going to be 1 cubed plus 1. So really, it's still the same integral, 1/3 u squared du, but my boundaries change. So plug 1 in for u. 1 cubed plus 1 is 2. And then plug in 0, 0 cubed plus 1 is 1. So you see how I changed the boundaries from 0 to 1 in t into u. Why is this nice? Well, when you integrate it here, it's much nicer because I could have just gone straight to, so you bump up the 1, divide by 3, from 1 to 2. So now I don't have to put it back into this t and do all that work I did over here. Remember all that? Why do that? Now look how easy peasy this is. And this is the way I prefer to do it, is you're going to say it's 1/3, 2 to the 3rd power, and that's all the first chunk, minus the second chunk when I put 1 in there. And it means the same thing. It's the same difference going on here. but it just looks nicer. Isn't that much nicer? So same thing, I get 2 times 2 times 2. I get my 8/3. I get my 1/3 over here, and then we take the 1/3 of that. So it's going to work out 1/3 times that 7/3 is going to be my 7/9. So we're going to do the change of boundary method. I just want to show you that it actually works. So immediately when we switch from t or whatever our variable is to u, we're going to switch these over. Awesome. Let's move on to the next one. So I try to throw a little trig function in here. So anytime I have a trig function, I definitely don't need, there's no angle, it's just x, so I don't need to put the u in there. So I'm going to probably start, and again, this is a guess, with the square root. What's on the square root? It's the sine of x. So I'm going to pick the more complicated one. And the derivative of sine is going to be what? Derivative of sine is cosine and dx. And then I think I have all my parts, don't I? Here is the u in blue. And then my cosine dx is here in red. There are my 2 parts. So I can just go ahead and rewrite this right off the bat. I can say the integral from u to the 1/2, or the square root of u, du. And I'm going to immediately change the boundary. So we're going to just go in the change boundary mode. So pi over 2 is going to turn into what? We'll plug pi over 2 into this. What is the sine of pi over 2? Well, the sine of pi over 2 is up here. That's 0, 1, so that is 1. And then plug 0 in. What's the sine of 0? It's 0, isn't it? So that actually stays 0. So check it out. That whole mess right there, just boom, simplifies into that. Use substitution. Love it. Love it. So let's integrate this. First, I like to rewrite it. So this is u to the 1/2 du. Now let's bump it up 1. So that becomes 3/2, and then divide by that, or flip it and put it in front there. And that's my integral. We're going to evaluate from 0 to 1. So I don't have to resub the sign back in there. I'm already good to go. It's just a matter of plug and chug here. The first part is 2/3 1 to the 3/2. And then that's this whole chunk. We're going to minus 2/3. I love putting 0 in there. 0 is so great to work with. So 1 to any power, but if you really want to write that out, you're more than welcome to. That's the square root of 1 cubed, but it's not going to matter. Same thing here. You can really write this out as the square root of 0 cubed, I suppose. But that's just 1. So it's 2/3. That's just 0 minus 0, so I end up getting 2/3 as my answer. Awesome. Super cool. So use substitution, but now we're going to take it all the way through. So we're going to go ahead and work it on out. Very nice. Let's move on. So we did a trig function. Let's do another one. We got e in this one. I thought I'd throw some e or natural logs at you. So again, before you start these, can I rewrite it? No, I can't rewrite this. Sometimes, you can, if the x was on the bottom, you can split the fraction. Is it an inverse trig function or something weird? So you got to double check those. Those they just don't disappear. Back from chapter 9, we did some of those. Not going to be one of those inverse tans or something weird there. So I'm going to try my u substitution. But I always try to rewrite first, and I'm going to throw a couple in the practice like that where, hey, you just rewrite it. So it's not everything in the practice won't be u substitution. Most of it will, but all right. So here we go. So I'm going to pick the bottom of the fraction. Remember, that's a whole group right there, the whole thing. So I'm going to try that as my u. And then the derivative of that is going to be what? That turns into 2x. The constant disappears. Dx right there. So I see the x on top. That's good. I see my x here, but I don't want that 2, so I need to divide by 2. So I'm looking at, it's really 1/2 du. Those cancel. X dx. So if you can see your x dx right here in red, in purple. Is that purple? Yeah, that's purple. We got the bottom. So what is this going to be? This is going to be the integral of really 1 over u du. So the du takes care of that, but don't forget about that 1/2 in front there. So now everybody's happy. I got all my pieces. Change this over. So e is going to disappear. Now this is going to be kind of weird, but don't freak out. Plug e in, you get e squared plus 4. That is a number. I don't have a calculator on me, but it's e squared plus 4. You could type that in and get some crazy decimal. 0 is much nicer. 0 squared plus 4 is just 4. Sometimes your boundaries will have to flip, like when you switch over that the top is smaller than the bottom. In this case, we don't. E squared plus 4 is bigger than 4, but sometimes you would have to be careful of that. They may rotate on you there. We're pretty coolio, though. So then I like to rewrite it, and I like to show my steps here because you can make little mistakes. So really, I like to take my time and show this is u to the negative 1. And what is that? Well, you can't bump it up. Remember, this is a special case where it's the natural log, and it's always the absolute value because natural logs are only positive. So we got to go absolute value of that. So we're ready to integrate it from here, and we've got this. And then there's a magic 1/2 out front. So we got that 1/2 out front. So let's plug this bad boy in there and see what we get. We are going to get, so the 1/2 is going to stay out front. The top number, that looks crazy, is the absolute value of e squared plus 4. And then I'm going to subtract, plug in your 4, the absolute value of 4. Now really these absolute values, do we need the absolute value of 4? No, 4 is already positive. So really this is just a natural log of 4. And that's also a positive number there, e squared plus 4. So it's something like that. We can put that in parentheses. You can put that one in parentheses if you really want to. And then we're going to half all of this mess. So I can half this. So really that's pretty good right there. If I have a calculator, I can make this a decimal. But we can actually use some properties here to clean this up a little bit. So you remember our log properties. It's going to come pretty big time next section, these log properties. Remember they have the same base, and if you subtract with exponent rules, it's like dividing. So this is really the natural log of what? Of e squared plus 4, all divided by 4. And then we can do 1/2 of that. So that's really, oh, can we go farther? We could go a little farther. Let's do it. If there's a number in front, what can you do with the number in front? You can bring it up as an exponent. So really you've got this e squared plus 4 over 4. Bring this 1/2 up here. Ooh, I like this. All right, keep on rolling. And what is that? That's really the square root of this thing. And then, well, let's keep it going. We can do the square root of the top over the square root of the bottom. Square root of 4 is just 2. So really the super cleaned up model would be this right here. Don't try to make that e plus 2. That's not legit because of the plus sign. That's as far as you can go. Don't overdo it. Don't want to underdo it. Don't want to overdo it. It's just right, like Goldilocks. That is the answer right there. So don't freak out if your boundaries look weird or you get stuck with no calculator. Go as far as you can without the calculator and just leave that e in there. Man, we are killing it. We only got one more example, and check it out. You can sit back and relax on this. This is a special case. Every now and then they're going to throw this on the AP exam. I want you to see it. It may every now and then have one. It's not the end of the world, but if you haven't seen it, you may just totally freak out. So it's not going to be on the master check. How about that? I'm not going to put it on the master check, but it'd be cool to see it. So again, this almost looks like a inverse tangent or something here going on, but it's not. It's not anything special. I can't rewrite it. So I'm going to do my u substitution. Now check this one out. You know, I'm going to do the square root and the bottom for sure. That's like a double whammy of the most complicated part. The derivative of that is just 1 dx. So what's different about this one? Well, oh man, I got this x up here and I don't have an x. Normally I have that x works out friendly. I didn't get rid of it. So if I try to rewrite this integral, you know, the bottom's pretty cool. It's the square root of u on bottom, but I still have that x on top. My dx can turn to du. So I'm pretty close. Like, this is pretty good, except I got that x there. So what am I done? Well, not really. We can actually solve for x, can't we? If you go back to this, u equals x plus 1. So just subtract 1 from each side. If you subtract 1 from each side, you get u minus 1 equals x. Like, these cancel. Oh, check that out. So I know what x is. X is actually u minus 1 all over the square root of u du. So now we're cool because we're all in u. And now we can do it. Now it's a special little rewrite. Like, we've got u. Split the fraction. I'm going to put this to the 1/2, that square root, minus 1 to the u to the 1/2. So I've got this thing going on. And then, remember your exponent rules. This is really u to the 1, so we subtract them. So this is going to equal 1 minus 1/2 gives me a 1/2. And then I could probably rewrite this as negative 1/2. So technically, this is the what I'm trying to integrate here. So I can integrate this no problem. Just take the antiderivative, so bump it up. That'll be 3/2. Flip it, multiply. And then over here, I'm going to bump that up to 1/2 and divide it by that 1/2 gives you minus 2. So that's it right there. This is an indefinite integral. I didn't have to do anything. I can sub the u back in. U is really x plus 1. So if I had to write this out, it would be 2/3 times the square root of x plus 1 cubed minus 2 times the square root of x plus 1. Very, very nice. Oh, plus c. Don't forget about plus c, plus some constant in there. So that's a throwback to indefinite because I didn't want to make up boundaries. I was kind of lazy and do indefinite. But I did want to show you that special case where, hey, I got this extra x. What do I do with it? You can solve for it and put it in there, and you're good to go. That's it right there. Just practice these. Always look for the rewrite or trig function. Not everything is going to be u, but practice these bad boys. Good luck on the math check. Peace out.